Bismillahirrahmanirrahim. Welcome to SLS Montessori and School. This is Aisha Wasim taking chemistry of class 9th. The topic of this presentation is taken from page 138 of class 9th chemistry book. This self-assessment exercise 7.5 says, sketch a voltaic cell labeling the cathode, the anode and the direction of flow of electrons. You are given with the following chemicals: silver, zinc, silver nitrate, and zinc sulfate. They have also given a hint here that zinc is more active than silver. If you pay your full attention and note down the important points, then you will be able to design a voltaic cell even if the chemicals are changed. You would also be able to label its different parts and understand the function of those parts of voltaic cell. You have already learned in the previous pages about the electrochemical cells, its types, and their function. Let us first see what is a voltaic cell. Any electrochemical cell that is capable of generating electricity by using a chemical reaction is called galvanic or voltaic cell. So here we are converting chemical energy into electrical energy. In these cells, spontaneous reactions takes place. These are those reactions that occur on their own. We divide the cell into two half cells. In one of the cell, oxidation takes place and the electrons produced as a result of oxidation travel through the external wire and reach the other half cell where reduction takes place, and this movement of electrons through the external wire is used to produce electricity. For this voltaic cell, we were given with two metals and two solutions. In constructing the voltaic cell, each metal is dipped in the solution of its ions. For example, a silver bar, that is the silver metal, will be dipped in 1 molar silver nitrate solution. Solution means that silver nitrate will be dissolved in water. When we dissolve it in water, it dissociates into silver ion and nitrate ion. The other metal given was zinc. So zinc will be dipped in the solution of its ions, means zinc ions. So for that, a zinc bar will be dipped into 1 molar zinc sulfate solution. Since zinc sulfate is present in the form of solution, so it is dissociated into zinc ions and sulfate ions. Then for it we need a salt bridge containing an inert electrolyte such as KCl. Inert means that the salt must not be reactive. KCl must not react with silver or silver nitrate, similarly with zinc or with zinc sulfate. For this we also need a voltmeter to measure current. Before making the sketch of the given voltaic cell, we should keep certain basic facts in our mind. Number 1. Oxidation always takes place at anode. Oxidation means loss of electron, so electrons will be lost at anode. Reduction always takes place at cathode. Reduction means gain of electron, so the metal ions will gain electron at cathode. Number 3. Electricity will flow from anode to cathode in case of galvanic cell because anode is losing electrons. Number 4. The more active metal will act as anode. Active metal means the metal that has more tendency to lose electrons. Number 5. Less active metal will act as cathode because here the metal cation will gain those electrons and deposit as the metal on the electrode. Now we will apply those basic facts to our given voltaic cell. Number 1. Zinc will be anode because it is an active metal. Number 2. Silver will be cathode because it is a less active metal. Number 3. Zinc will be dipped in zinc sulfate solution. As I stated earlier that metals are always dipped in solution of their ions. Similarly, silver will be dipped in silver nitrate solution. Both the electrodes will be connected through external wire and then the solution will be connected through salt bridge to maintain the ion contact. This is the sketch of the voltaic cell. Here have a look that I have labeled zinc as anode. Because zinc is an active metal, active metals have more tendency to lose electrons. So zinc will convert into zinc ions and 2 electrons. Zinc will enter in the form of zinc ions in the electrolyte and these 2 electrons they will travel along the external wire and reach the other electrode called the silver cathode. Silver is also a metal, means it has the tendency to lose electrons, so the electrons coming from the zinc anode will not be gained by the silver cathode. Rather, the silver ions that are present in the electrolyte, they will gain these electrons and convert into silver metal. Since silver can gain only one electron because it has a single positive charge, so for gaining these 2 electrons, 2 silver ions will be required and they will convert into silver metal. This silver metal will be deposited outside the silver cathode. Here we need a salt bridge in order to balance the ions in both the electrolytes. Here we are getting more and more zinc ions, means positive charge will build up in this electrolyte. To balance this positive charge, negatively charged chloride ions will start getting dissolved in this electrolyte. While in the other electrolyte, silver is being removed from the solution when it converts into silver metal. So, there will be a shortage of positively charged ions. To compensate these positively charged ions, the potassium ions will get dissolved in this electrolyte. So, again the charges, the positive charge and the negative charge will be balanced in this electrolyte. I hope this presentation will be helpful in learning how to draw a given voltaic cell. Allah Hafiz.